All right, good morning, everyone. We are going to take a look at some more ways that we can get better at determining our hypothesis tests. So, using that table that we looked at yesterday, we need to be all on the same page as to when to use each hypothesis test, and then going one step further, once we've decided which hypothesis test we should use, figuring out our test statistic. So which table should we use to find our p-value on, and so on. So I've created this drill here, so I want you to just pause this video, and I want you to try and figure out what type of test statistic we'll use, whether it's a z, t, or chi-square, based on the information given in the left-hand column, and then write out how you would actually calculate that test statistic if you do have enough information to calculate the test statistic. So go ahead and just take, let's say, 3 minutes on your own. So just pause the video, and then we'll come back together for the solutions. All right, welcome back. So based on your answers, let's see if you have them right. So looking at this, we have n equals 49, confidence level 0.9, type of test, goodness of fit. So goodness of fit, we would use our chi-square, so that's going to be equal to our observed minus the expected quantity squared over the expected. Here we have n equals 24, confidence level 0.95, type of test, different of sample proportions. Well, since this is a proportion, this would be a z-test, and so we would have z is equal to p hat 1 minus p hat 2, quantity minus 0, over the square roots of p times 1 minus p, p1 over n1, then plus p2, 1 minus p2 over n2. So that would be our whole formula. Next one, type of test is homogeneity, so chi-square again, and then technically we are using the same formula as above, but I'm just going to write that we are going to use the matrix test in our calculator. That's how we get the test statistic. One sample proportion here, so again proportions is z's, so z is equal to p hat minus p over square root of p, not p hat, 1 minus p over n. And then a one sample mean here, well, this one is kind of a trick question because a one sample mean could be a z or it could be a t. So you would actually need more information. So let's just go ahead and write if we would use a z, that would be if we have x bar minus mu over sigma over the square root of n. But if this were a t, then we would have x bar minus mu over s divided by the square root of n. And then lastly, if this was a least squares regression test, then this would be a t. So we'd have t is equal to the slope minus 0 over our standard error of the coefficient. All right, hopefully you got those right. If you didn't and you understand why you got them wrong, that's great. If you did not, please join the Zoom call at 8:20 so that we can get some clarification on that. All right, so let's go ahead and look at this problem here, where we are trying to, again, just get used to figuring out the type of test that we are doing, and then what computations we need. So let's just zoom in on number 1 here. So our prompt, we should extract all the key information given, and then we should record that information in the prompt or in the box from the prompt, and then let's just go ahead and dive in. So in a recent Zogby International Survey, 11% of 10,000 Americans under 50 said that they would be willing to implant a device in their brain to be connected to the internet if it could be done safely. What is the margin of error at the 99% confidence interval? Okay, so looking at this problem, I see that, again, we have a percentage given. So this is a good indication that this will be a proportion. And then they said of 10,000 Americans, so that is going to be our N here. So let's just go ahead and write that. So another reason why this is N and not the population, first of all, there are definitely more than 10,000 Americans in the population, but they found this information from a survey. So I know that this is them conducting a sort of sample here. So N is going to be equal to 10,000. And then our P hat is going to be equal to 11%. So again, this is P hat, not P, because we are using the survey. So this is a sample proportion, not the population. And then they give us that the confidence level is 0.99. So what conditions do I need to meet? Well, I need to meet my RIN. So did they take this sample randomly? Is it independent? So meaning, is my sample size over the population? Is that less than 10%? And then lastly, do I meet the normal condition? Well, we already said this is a proportion, so I know that I must meet these two conditions. N times P is greater than 10, and N times 1 minus P is greater than 10. So that's my normal conditions here. And then I know that based on this, if I were to meet these conditions, my computations, they're asking for the margin of error. So I know the margin of error is going to be my critical value. So let's write error is equal to the critical value times the sample standard deviation. And so here, since this is a proportion, my critical value is going to be a z. And then my sample standard deviation is going to be my p 1 minus p over n. Now I know you're thinking, well, wait a minute, we don't have a p. They didn't give it to us in the problem. Well, that is the situation in which you would just substitute in p hat rather than p. So the rule of thumb is, if we have a p, use it. If we do not have a p, then p hat will just suffice. So if you're given both, use p, but if you're only given p hat, then that's just what we have to use. So that's what we would sub into this formula here. So I'm not actually going to solve out this problem. I trust that from this information you could solve the rest of this, but we're just going to actually just pause, just so that we're all on the same page of getting the information from the problem and knowing what to do with it. So the computations aren't so important as to knowing what to do with the information. So let's just go ahead and move on to number 2. So in an SRS of 80 teenagers, the average number of texts handled in a day was 50 with a standard deviation of 15. What is the 96% confidence interval for the average number of texts handled by teens daily? So here, the key information given to me, they said they took an SRS of 80, so N is going to be 80 here. They found that the average number of texts was 50, so that's from the sample. So I know that that is my X bar, because X bar is the sample mean. And then they, with a standard deviation of 15. So again, this is from the sample, so this is going to be S is equal to 15 rather than sigma, because sigma would be the population standard deviation. However, this value is coming from my sample, so this is S. And then they give me my confidence level of 0.96. So again, the conditions that I need to meet: did they take the sample randomly? Is it independent? So again, n over the population has to be less than 10%. And then a normal condition, since we are dealing with means here, the normal condition is just n greater than or equal to 30. And then they want to know the whole confidence interval. So my computations over here, we know that the confidence interval formula is our statistic plus or minus our critical value times our sample standard deviation. So I know my statistic is my x bar here, plus or minus, and then my critical value, it could be a z or it could be a t. So I need to figure out which one it's going to be. So I want you to pause the video and think about, how do we know when we use a z? How do we know when to use a t? So I go back to my problem and I see, okay, we found s is 15. So I know that s's indicate that I'm going to use a t statistic or a t critical value if we're using a confidence interval rather than a z. So here we're going to have t times our sample standard deviation of s over the square root of n. So again, I trust that you can finish these calculations, and then let's go ahead and move on to number 3. So acute renal graft injection can occur years after the graft. In one study, 21 patients showed such late acute rejection where the ages of their grafts in years were, this list of numbers respectively, establish a 90% confidence interval for the ages of renal grafts that undergo late acute rejection. So this is an interesting problem here. We've never really dealt with one where we have a list of data points, but let's just go ahead and see what this is going to look like. So I see they said in a study 21 patients showed, so I know that we found n to be 21 here. And then I need to see, okay, is this going to be a mean or a proportion, or are we going to do chi-square? Let's see what this is. So I'm not seeing any categories listed, so I don't think it's going to be chi-square. I just see a list of data points, so there's not really any percentages going on here. So this isn't going to be a proportion. So now I'm within the mean realm. So I need to decide, is this going to be a paired t, a one sample mean, or a two sample mean? Well, it only says that we took the study once, so we only have one sample here. So this is either going to be a one sample t or a paired t. Well, again, I know that in a paired t-test, we still take two samples. So here we're not taking two, so I know that this is going to be a one sample mean. So now that I've narrowed that down, I need to determine, okay, how am I going to find the information that I need? I know that I need a mean and a standard deviation, but how am I going to find that? So I want you to pause the video and think about how would you find this information? Well, to actually find it, we would need our calculator. So if we went to our calculator, let's actually just go ahead and go to that now. We would go to Stats, Edits, and then in List 1, we would enter all of those values. So 9, 2, 7, 1, 4, 7, 9, 6, 2, 3, 7, 8, 2, 3, 1, 2, 3, 1, 1, 2, 7. Okay, so I've entered all of those values in my list. I go back to Stat, Calc, and then one var summary. Actually, let me clear that out. So Stat, Calc, one var stats, calculates. So then I see my X bar here is 4.14, so that's going to be my sample mean. And then since was a sample, not the population, we would use S for our standard deviation. So let's take note of that. So again, X bar is 4.14, S is 2.87. So going back to here, we found X bar 4.14, S is 2.87, and then they gave us the confidence as 0.9. So the rest of this is just going to follow from number 2, so I can actually just copy this. Maybe if it'll let me copy. Copy, paste. Excellent. Great. All right. And again, since this was a sample, we used S, and then since we have S, we would use T as our critical value here. All right, so I want you to do the same thing for the next 2 problems. So again, if you have any questions, please log on to the Zoom call at 8:20, and I can answer any questions that you have. All right, other than that, please make sure you submit by 5 o'clock today. Have a great rest of your day, everyone.